Our next lesson is called Exploring the Symmetry of Graphs of Quadratic Functions, Day 2. We are going to revisit all of the parts of the quadratic function that we learned about in the previous lesson. In the previous lesson, however, we used the graph to find these parts or features. Today, we are going to use algebra. So we'll start with axis of symmetry, just like we did in the previous lesson. The quadratic still needs to be in standard form, and it's still a vertical line, but that vertical line now has to be found algebraically, so we're going to use an equation, and the equation is x equals negative b over 2a. So we will go down here to the area for work, and you will see that the graph is blank. There's no table of values. We're going to find everything algebraically and slowly fill this in and create the graph. So if this is axis of symmetry, and I see this on my paper and I do not have a graph, I need to remember this is in standard form. So this is A, B, and C. Your A value is 1, your B value is 4, your C value is 3. We will use the formula x equals negative and then b over 2a. Keep that negative out in front. It will remind you that if there's a negative value for b, that you include both. Don't drop that original negative symbol. Okay, so that means this is negative. Our b value is 4 times 2 over 2 times a, which is our a value is 1. So that means this is negative 4 over 2, which is negative 2. So we still get the same axis of symmetry as we did the day before, but this time we found it algebraically. So this is automatically going by ones. We do not need to fill in the numbers. We will go ahead and plot our axis of symmetry since we found it at x equals negative 2. And we'll label it as x equals negative 2. So you can find the axis of symmetry algebraically. You do not need to find it by the graph. So if you recall from the previous lesson, we found the axis of symmetry on the graph, and then the vertex was where the axis of symmetry and the graph intersected. Obviously, we can't use that when we're doing it with no graph, so let's look what we do algebraically. For the vertex, it's still the point, so we're still coming up with a point, where the graph, right, of this quadratic function and the axis of symmetry intersect. But this time, we don't have a picture. However, we do have the x value already. So we are going to find the y value given the x value of the axis of symmetry. So going down here, in order to find the y value, we have to use the actual function itself. So we're going to use f of x equals x squared plus 4x plus 3. Now, we already found the axis of symmetry above. So we're going to take that axis of symmetry and we're going to use it in number 2. So we have f of negative 2, because that's our axis of symmetry, is equal to, I'm going to do my outline so that I can color code this for you and see that the negative 2 is what's being substituted in. So we've got negative 2 squared plus 4 times negative 2 plus 3. So you find your axis of symmetry first. That gives you the x value. You then use the quadratic equation itself to plug in your x value and find your y value. Okay, so we've got f of negative 2 equals negative 2 in parentheses squared is 4. 4 times negative 2 is take away 8 here, or minus 8, and then plus 3. So our f of negative 2 value is negative 1. So that means our axis of symmetry, our vertex is negative 2 from the axis of symmetry x value, and the negative 1 that we just found, this is our vertex. So now we can go plot that point. Negative 2, negative 1. Next, we have to figure out the end behavior of the graph. This is our third vocabulary word from yesterday that was brand new to us. So here, end behavior of a graph. we have to figure out if it opens up like a smile or down like a frown, but not be able to look at the picture. So if you look at the quadratic function in either form, now, we're currently using standard form, but there is another form coming up that we'll be learning about that's next to it. For either one of these, the quadratic function is said to open up if a is greater than 0, which means it's positive, and open down if a is less than 0, which means a is negative. So reminder, open up means it's got the U shape. Open down like a frown means it's facing downwards like an arc. So if I look at our equation, our a value was a 1. That means our a value is greater than 0, or in other words, positive. So that means our end behavior is opens up, and it's going to look U-shaped. All right. So then we can find the zeros or the roots. So the zeros are the x values of the x-intercepts, if you recall. So I'm going to write this next to it like x equals what when y equals 0. That's what you're trying to figure out. So we once again are going to use our actual quadratic function. F of x equals x squared plus 4x plus 3. If we're trying to figure out what is x when y is 0, y is the same thing as f of x. So we're going to replace f of x with 0. And we're going to do equals x squared plus 4x plus 3. That should look extremely familiar. We were finding the zeros of a quadratic function for the first 3 lessons of this chapter. You just didn't look at it from that perspective. We were setting quadratic functions equal to 0 so that we could factor and then solve them. So that's what we're going to do here. We have 0 is equal to, we want the factor pairs of 3 that add up to 4. So that would be 1 and 3. So this is x plus 3 and x plus 1. After we factor, we know we're going to t time. Set each factor equal to 0 and solve. So we'll subtract 3 on this side, x equals negative 3. We'll subtract 1 from this side, x equals negative 1. So the roots are x equals negative 3 and x equals negative 1. Now I want to make a little note about this. Those are the x values of the x-intercepts. So remember, negative 3, 0, and negative 1, 0 are the x-intercepts. So the roots are the x values of those coordinates. Now finding the y-intercept, I want you to think about this as x is 0, what is y? So once again, we are going to use our quadratic function, f of x equals x squared plus 4x plus 3. But we're going to find f of 0. So that's going to be whatever x is squared plus 4 times x plus 3. And I'm going to replace everything so that you can see nice and color-coded that I'm putting in 0 in all of the x's positions. So that means f of 0 is 0 plus 3. So f of 0 is 3. And that means that 0, 3 is my y-intercept. And then remember our symmetric property we can use from there. So let's go up here and actually plot our zeros. So we have x equals negative 3, x equals negative 1. So we're starting to see it form. We just found our y-intercept is 0, 3. So the next point we want to get is the symmetric one. So I'll make a little note. It's 2 away. So we want to make it 2 away the opposite direction. which means negative 4, 3 is the symmetric point. And so now we should have enough to put these values in our table and make the rest of our graph. And we can go ahead and know that the vertex is going to be in the middle. So that was negative 2, negative 1. We know our roots are next. If we look at that picture, so negative 3, 0, and negative 1, 0. And then we had our y-intercept, which was at 0, 3, and our symmetric point is negative 4, 3. So now I can go ahead and draw in the parabola U shape for my quadratic function y equals f of x. Now, one additional note I want to talk to you about before you try your practice is that there's actually another way to find the zeros or roots. You can find the axis of symmetry and vertex by doing it from those roots. So if you have the zeros or roots, let's start there. We do. All right, we know what they are. We can take and get the axis of symmetry by doing the first root plus the second root and dividing it by 2, taking an average. So our first root was negative 3. Our second root was negative 1. And if we take those things and divide by 2, we get negative 4 over 2, which is negative 2. So you'll see the same answer from before, x equals negative 2, as your axis of symmetry. The reason we're able to do this is because these points are symmetric. So if you take those roots and average them, you'll end up with the middle value, which is the x value for your axis of symmetry. So we'll make a little note on the side for axis of symmetry. We use the function to get y for the vertex. So we could get to the other key features and things that we need to find if we give a different starting point of the roots instead. So what I'd like you to do now is take all that information that we just discussed together and try the practice questions. I want you to try question 1 and question 2. And then when you're done, you can resume the video to go over your answers. So at this time, please pause the video and try the 2 practice questions, then resume when you are done. All right, now that you had a chance to try the questions on your own, let's go over the answers. So we identify A, B, and C. In A, they asked us the values of A and B because we're going to need that for the equation of the axis of symmetry. So the A value is negative 2 and the B value is negative 12. So when you use the formula negative B over 2A, x equals negative B over 2A, you have the negative out in front and then you're putting a negative 12 in B's position. On the bottom, you're doing 2 times negative 2. So that's a positive 12 divided by negative 4, which is negative 3, which means your axis of symmetry is x equals negative 3. Now, to find the vertex, you just have to find the y value that goes with that x from the axis of symmetry. So you're going to use the quadratic function. You are going to replace the x's with negative 3 since that was our axis of symmetry. And when you evaluate that, you find the y value is 32. So your vertex is negative 3, 32. So what is the end behavior of this function? The A value is negative 2. So since it's less than 0 or negative, that means it's going to open down like a frown. So that means that that turning point vertex is actually a maximum. Looking at question 2, you're going to consider this new quadratic function, and I wanted you to find the zeros or roots. So you have to find the x values when y is 0. So we replace f of x with 0. We factor x squared minus 14x plus 45. And then we get x equals 9 and x equals 5. So then how far do both zeros lie away from the axis of symmetry? Well, let's find where the axis of symmetry is. We don't know for this problem. So since we have the roots first, we can average those to find the axis of symmetry is x equals 7. So that means 5 is 2 away and 9 is 2 away. So they're both 2 units away from the axis of symmetry, which makes sense because it should be symmetrical. Then using your calculator, you're going to go to the y equals screen and type in this quadratic function. Using what you know and looking at the table, you had to create a table of values for this function that illustrates the symmetry about its x-axis. So we know the roots are at 5, 0 and 9, 0. We now know the axis of symmetry is x equals 7, so we can go to our graphing calculator and find 7 and see that -4 is across from that. And then you need to scroll until you find the next symmetric point. Those would be 0.45 and 14.45. So this concludes your lesson on exploring the symmetry of graphs of quadratic functions, day 2.